Okay, this is a quick introduction to ocean geography. So one of the things when we're looking at the oceans and kind of figuring out where we are in the world is we have a globe and we have a map. And I want to point out, first of all, that 2D maps are going to be distorted images of the continents. But whether we're using a map or whether we're using a globe, we depend on a coordinate system to kind of locate where we are on Earth. And so that's what we're going to start with first. So when you see lines running horizontally, the most memorable line is the one that starts at 0, which most of you now know is the equator. And so these are lines of latitude. A lot of teachers teach you that latitude is flat, and that's how you can remember it. And so here it shows lines of latitude going up. So these lines here, they're running north and south. And so this would be 15 degrees north. And a lot of times what people do when they look at this is they think, oh, I should label this east because they're used to the right side of the paper being the east side of the paper. But the lines are indicating something else. So this would be 15 degrees north. So everything in North America would have a latitude, a northern latitude. If you were in South America, except for right up here, you would have a southern, or sorry, you would have a southern latitude. Then you may ask, okay, so how far does this go? Well, this map here goes to 75, but as you can see, this is not the end of the world here. And 75, it doesn't end up here. So the poles are at 90 degrees. So you have 90 degrees from here to here, another 90 degrees from here to here, the other pole. This is not cooperating. And so if you do that back up, you get your complete 360-degree circle. So those are lines of latitude. North Pole is 90 degrees, South Pole is 90 degrees. Here are the increments in between. Let's talk lines of longitude. Now, the equator, when we talked about latitude, the equator made a lot of sense of deciding where the equator goes because normally a lot of the year this is where the sun is directly overhead. And so the lines of latitude really change the climate depending on where you're at. The further away from the equator, the less direct the sun's rays are, and so you get typically colder latitudes as you move away from the equator. With longitude, there's no clear distinctive point, so where do you make your 0 mark? And because of who was kind of in charge at the time of making maps, it defaulted to England. And so passing through England is the prime meridian. By the way, this is a super outdated globe, in case you're noticing. So we have our prime meridian, which is our 0 line of longitude. And on here, you can find England over here. There's our prime meridian, which means that these lines on either side are not going to be marked northern, they're going to be marked east and west. So everything in, well, and let me show you this here. So everything in Europe and Russia, Russia and China, this is all Eastern. A way I remember that is a lot of times we refer to Eastern medicine, which Chinese medicine is usually called Eastern medicine, and then, you know, the pharmaceutical industry is usually called Western medicine. Not completely, but that's kind of where you typically hear it. And so Western medicine, you know, is more European and Americanized anyway. All right, so prime meridian, eastern side. How far do you label these east? Well, you go from 0, blah, 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 blah. You're continuing to rise. All of a sudden, you hit 180, and now you start dropping again. So 180 degrees around the world is halfway around the world, and this is what we call the international date line, because at some point, the date has to change, and we decided that it made a whole lot more sense to make it's Sunday here and Monday here at this point in the globe, because there's not a whole lot of countries and not a lot of landmass that's going to be affected by it. So there's a great question, like if you wanted to have your birthday and celebrate it as long as you possibly could, well, New Zealand is going to, or even the New Year, right? So New Year's Eve is going to happen first in New Zealand and Australia, and then it'll happen here, and then it'll happen in New York, and eventually after New York, New Year's Eve will hit Seattle, and last but not least, well, Hawaii, and then the islands that are lining the prime meridian. And then the date changes. So that's the significance of the prime meridian. What else? Longitude. So we can use latitude and longitude to navigate, and that's in the next video you can see there. One other thing I wanted to talk about is kind of why we have these additional lines of latitude that we call the Tropic of Cancer, the Tropic of Capricorn, the Arctic Circle, and the Antarctic Circle. So those were things you were supposed to draw on your map here. A lot of people didn't actually look at the numbers and wanted to put the Tropic of Cancer at 15 degrees, but it's really at 23.5 degrees. And you may think, well, why 23.5 degrees? That seems kind of odd, but the 23.5 is significant because these lines are significant. So when you look at the tilt of the Earth, you may ask, okay, how much is the Earth tilted? Well, it's tilted on its axis 23.5 degrees. So I got a little demo here of what this looks like, where, sorry about the camera here, these are not exactly 23 degrees, nor is the Arctic Circle exactly where it should be, but generally this is kind of the layout here. You've got your equator, you've got the Tropic of Cancer in the northern hemisphere, the Arctic Circle up at the Arctic Ocean in the northern hemisphere, Tropic of Capricorn in the southern, and Antarctic Circle near Antarctica. So why this? Well, assuming that, let's pretend that the sun is shining from over here in our image. The rays are going to be the most direct here at the equator. They're going to get a less and less and less direct as you move away. And so this is where the intensity of the sun is the strongest. On the equinox, equinox gets its name because it sounds like equator. On the equinox, this is how things look. But as the Earth moves around the sun, where the tilt doesn't change, but whether you're tilted towards the sun or whether you're tilted away from the sun does change because of how you're moving. So it's kind of hard to demo here with one hand, so I'm not going to do that. But let's see, where was I? The tilt. So I'm going to show you what it looks like when it's tilted, although I don't want you to confuse this thinking that the Earth tilts. It's really where the Earth is. So let's say the Earth looks more like this. And these circles don't line up perfectly. But here, the sun is directly overhead, not at the equator, but at the Tropic of Capricorn. So this would be winter time for us in the northern hemisphere because the sun has shifted south. Now, it's still pretty darn hot at the equator, you know, and the tropics in general are always warm and pretty good weather. But right now, the Tropic of Capricorn would have a little bit longer days than the Tropic of Cancer. And if you were, and so actually this is what it would look like on the winter solstice. It'd be extremely over, and on the Antarctic Circle, if you were anywhere within the Antarctic Circle or above, you would have no daylight on that day. And that's why we made the Antarctic Circle, is because on the shortest day of the year in the Northern Hemisphere, there's no daylight. The sun does not rise above the horizon at the Arctic Circle. I might have called it Antarctic a second ago, but I did not mean that. Now, that is December 21st. December 21st, then we get to March 21st, and we're back to an equinox because of, again, not the Earth moving on its axis, but how the Earth is positioned in relation to the sun. This is what it looks like on June 21st. Now the sun is directly overhead at the Tropic of Cancer, and the Arctic Circle has 24 hours of daylight. How sweet would that be? Whereas the Tropic of Capricorn has a little bit shorter days, a little less direct sunlight, and it's now the Antarctic Circle who's in 24 hours of daylight. So that's why these lines exist. We talk later about using those lines to navigate and to figure out where you are in the world. And this is an intro to geography. Thanks for listening. Please subscribe to my channel.